Hello everyone. In this video, I'm going to explain problem number 2.17, which is the example problem from your textbook. And the statement of the problem is a 2 kilowatt resistance heater wire whose thermal conductivity K is given, and the diameter of the wire is given, and length is given, and it used to boil water. So I just captured the wire, and he has give the details on this wire are there, physical dimensions, and then continuing further, if the outer temperature of the resistance wire Ts is 105, here is a Ts 105, determine the temperature rise at the center of the wire. So his interest is to find the temperature at the center of it. That's one part of the question. The second part is, what is the maximum temperature rise in the wire? So basically what he's asking is, how much temperature has been risen in this wire. So delta T is what he's looking for. Okay. So given that, what I have done is I transposed all the pertinent information into my worksheet, and as you see, TS is there, 0.5 is the length of it, 4 millimeter diameter, and thermal conductivity is there, and rating of the heater is also here. What is the assumptions? Heat transfer is steady throughout the wire. It's a steady heat transfer, one dimensional, because it's cylindrical, and the direction of heat is towards the from center to the outer radius, which is perpendicular to the surface of the surface area, and K is constant throughout this. The conductivity, thermal conductivity is constant. And simple geometry, volume of wire is pi r square L, and so all the information is here. So what is the mechanism here? Whenever they give you this wattage, the power rating like this, what it means is, for example, 2 kilowatt resistance wire here means it converts electrical energy into heat. So the rate of heat generation is a resistance in a resistance wire is simply power rating. So when they give you 2 kilowatts, it automatically means E, capital E dot, heat generation, and that is always in watts. See this? The unit is E. That is what he has given. So now to solve the problem, so as a result of that heat, what's happening? The temperature has risen to 105 degrees outside temperature, but we don't know the center. That's what he's asking. So let's tackle the first question. The first question is to find out, so what is the relationship for the, first of all, let's find out energy generated per unit volume. Small e equals total energy, rate of heat generated divided by the volume. So since we know total heat generated is 2 kilowatts, which is 2000 watts, let's put into the watts here, and the volume is area pi radius square. I'm putting everything in meters here, and length of the wire. So simplifying this, you will come up with the answer of 0.318 10 to the power of 9 watts per meter cube. Pay attention to the units. Volume, heat generated per unit volume is watts per meter cube. So we have that. Now, what is the formula for the center line temperature? Formula for the center line temperature, that's what we want to know, is T0, that is center line, plus T surface, plus volume generated per unit volume, heat generated per unit volume, sorry, and then radius square divided by the 4K, 4 times thermal conductivity of the heat wire. So we know pretty much all this information here. TS is 105 degrees centigrade, plus we just calculated heat generated per unit volume, which is 0.318 times 10 to the power of 9 watts per meter cube, and radius square 4 millimeters. Half of that is 2, and converting into radius square divided by 4 times thermal conductivity, which is given 15 watts per meter Kelvin. So you see how all the information is there. So you simplify this and you come up with a 126 degrees centigrade. All the meter cube will get cancelled, watts will get cancelled, and you end up with a degrees centigrade. So that is the first part of the question. That is the maximum temperature raise. Ts is 126. T0 is 126 degrees. What is maximum temperature rise? Second part of the question. The second part, very simply, is nothing but T center line minus T surface. Simple. So center line is 126 degrees, and we know the surface temperature 105, and that is comes out to be 21 degrees centigrade. Just to summarize this problem very quickly, whenever they are looking for center line temperature, first you find out energy generated per unit volume, and so to do that you take the power rating of the wire, which is 2000 watts, and you calculate energy per unit volume, and then they use the second formula, which is T center line equal to Ts plus energy generated per volume times R radius square by 4 times the thermal conductivity, and you find the value. And the second part is much easier. All it is temperature rise. I just wanted to point out to you, whenever they say temperature rise, all it means is the delta T between center line and outside. Okay, I hope this video helps you understanding how to calculate this center line temperature and also the temperature rise. Okay.